So simplifying fractions, it kind of works like this. Let's look at an example. So for example, it's like saying, well, if I had a sandwich like this, right? Make it colorful with some lettuce, some mayo, and bacon. I don't know, whatever you put on a sandwich, okay? Maybe it's PB&J, whatever. Well, let's take the sandwich and we're going to cut this up into 4 parts. Now, we would assume those are equal parts, but my drawings aren't great. In any case, let's say that I gave you 2 pieces, right? Then as a fraction, it would be 2 out of 4 pieces. Well, if I gave you 2 pieces, maybe you got this part of the sandwich, right? Well, how much of the sandwich is that? Actually, it's the same as 1/2 of that sandwich. All right, so simplifying fractions is like that. It's like saying instead of comparing 2 and 4, I want to compare now 1 and 2. The method on this is going to have to do with the factoring that we did on that last part. All right, so number 1, circle the fractions that are simplified. Assume no variables are equal to 0. The reason that's the case is because we can't have 0 in the denominator, which we've looked at before. We can't divide something by 0 because it's undefined. So 1a right here, this one could be simplified further. Why? Because if I were to split these up, okay, 12, let's look at the prime factorization on this. I could split this up into 2 and 6. 2 is prime. And 6 splits up into 2 and 3. So 12 is really 2 times 2 times 3. Now on the other hand, 28 can split up as well into, let's say, 4 and 7. 7 is prime. And then 4 splits up into 2 and 2. So 28 is really 2 times 2 times 7. And if we split these parts up, then I've got 2 divided by 2, 2 divided by 2, and 3 divided by 7. And what that means is that I can cancel these out because they become 1s. Anything divided by itself is 1. So the simplified form would have been 3/7, which means that this one is not a fully simplified fraction. So on 1b right here, another way to know if it's simplified is to see if both numbers could be divided by the same thing to give us something smaller. Well, 18 and 24 are both even, so we could at least divide these by 2, and we would get whole values, 9 and 12. That shows a simplified form of that fraction, which means that this one is not a simplified form.
13 is 13. 1 times 5 is 15.
That's,
1 times,
yeah.
1 times 15. 15 is 15.
Very good. 13/15. This one is simplified because 13 is prime, so its only factors are 13 in itself. 15 could be divided by 1, 15, and then 3 and 5, which shows that we couldn't divide both of these by the same thing to simplify it. So it is already simplified. We could. And here's what. So, and this comes with a little bit of experience, but looking at this, we got n divided by n. Well, what's anything divided by itself? 1. So the actual simplified form of this would be 1. So this one is not fully simplified.
Oh. Same with 3.
Very good, yep. This 3 divided by 3 is also 1, so this one is not fully simplified either.
Fraction.
Well, as it turns out, this one is. Because, I mean, we could write this differently as 7, but keeping it as an improper fraction shows that it is fully simplified as well. So as it turns out, this one would work. And even if we just had 7, that would be the case. So 1g also, that's as simplified as we can make 5. Right there. Write a fraction that is equivalent to 9/4 with a denominator of 24. So for this one, we got 9/4, but again, it's like we're splitting that sandwich up now instead of 2/4 parts into 24th parts. So on this one, we got to look at 4, and how do we change 4 into 24 is really what we need to look at there. Okay. By 6, very good. So if I multiplied this 4 by 6, I would get the 24. But in order for me to have an equivalent fraction out of that, then I would have to multiply the numerator by the same value. See, what that does is it scales this up. That's 54. It scales this up, but again, the value of it is all the same. Because I'm multiplying those numbers by the same value, we could also look at this, not that anyone likes this method, but 6 divided by 6 is 1. So it's like we took that fraction, multiplied it by 1, and got something else. Now it's the same value, but we're using different numbers to show the same value, right? It's similar to having 2 quarters, which is 50 cents, right? Or 5 dimes. Does it matter which one you have? No, you have the same amount, but you're dividing it up differently.
So that's the same thing.
Yes.
Equivalent to 9/4.
Yeah, so, but let's not use the same one that we did.
Oh.
Okay. So if I had 9/4, let's write this differently. So notice what we did on that last problem, right? We just multiplied the 9 and the 4 by the same number. So to scale this one up, to make it a different fraction that has an equal value, what number do you want to multiply the 9 and the 4 by?
Don't you gotta do it so it makes it equal?
So you just got to choose any number other than 1. Well, and 6.
You have to do 3, right?
You could do 3, but scaling like this means that, and we're multiplying, means we could multiply it by anything. So let's use 3. See, if I multiply these by 3, then I get 27/12, which has the same value as 9/4. Let's say that we wanted something else, though. Let's multiply these by 2. Well, that means that 9/4 is the same as having 18/8.
So you pretty much do.
Let's look at this even differently, and maybe this will help. 9/4. Let's multiply both of these by 10. Well, then I would have 90/40, which again has the same value as 9/4. All right, so let's go ahead and simplify some of these. But on this one, 12 and 28. So simplifying means that we're going to divide these by something, okay? And both of these are at least divisible by
6.
6 doesn't go into 28 evenly,
Oh.
right there. 12 is, though, right? So again, we can look at this. We got the 12 and the 28.
So it would have to be 2, right?
Well, let's split them up. Let's split them. So 2, yeah. 2 works. 12 splits up into 2 and 6. 6 splits up into 2 and 3. So I'm going to write this instead of looking at the dividing part right here. I'm going to rewrite these as their prime factors. So I got 2 times 2 times 3. And 28 I can split up into 2 and 14. 14 I would split up into 2 and 7. So 28 becomes 2 times 2 times 7. In any case, this is 2 divided by 2, which is 1. 2 divided by 2 is 1. So those cancel out, and all I'm left with is the 3/7.
Isn't there a super?
All right, but you should still show work on those, right?
Yeah.
All right, let's look at, I'm going to do the prime factorization on this one as well, and then I'll show you guys kind of the dividing way to do it. So on this one, we got the two numbers, 18 and and 24. Let's split these up. 18, I got 2 and 9. And 9 is 3 and 3. So 18 is really 2 times 3 times 3. Now if I can find any common factors for 24, then I can cancel those out. So 24 splits up into 2 and 12. You could have used 3 and 8 if you wanted to. But 12 becomes 2 and 6. 6 would be 2 and 3. So no matter how you split up the 24, you should still end up with these four numbers. 2 times 2 times 2 times 3. So what can we cancel out here? I've got that set of 2's. Now it didn't matter which purple 2 I crossed out there, all right? But I just chose that one. Then I've got that set of 3's which cancel. So what I end up with is 3 over 2 times 2, and 2 times 2 is 4. So this is my final simplified fraction. Like on this one, if we know something that we can divide both of these by, something that's divisible by both these, then we can divide both of them. Yeah, and 10 would work. Let's divide both these by 10. So 130 divided by 10 is 13. 150 divided by 10 is 15. All right, is there anything else I could divide both these by to make these both smaller?
No.
Not if I want whole values. So yeah, this is actually the final answer on that. Now, the thing about this is we had to know that we could divide both of them by 10 or 5. Because you could have divided them by 5 and then divided those two numbers by 2 if you wanted to. But 10 is kind of the quick way to get to that. Now, if we'd used prime factorization, we would have canceled out 2's and 5's. And then we would have been left with 13 and then eventually 15. So that's now I'm focused on the factors on this case. So if you do have numbers ending in zeros, you can cross them out, which is okay. That's okay. That's essentially what we did by dividing by 10. Couldn't use that same rule, but let's try this one. So the first thing I noticed about these is that 18 and 74 are both even numbers. So I could at least, at the very least, I should be able to divide both of these by 2. So 18 divided by 2 is 9. 74 divided by 2, 37.
Then you gotta go 2 divided by 37 and 9 again.
Kind of. On this one, so 9 I could divide by 3, right?
Oh, yeah.
37 I could not divide by 3, though.
Oh, neither can you do by
So as it turns out,
that's
your final answer. Right? All right, so let's do it that way on this. So we got two numbers, right? 40 and 56. Let's go ahead and split these up. 40 would split up into 4 and 10. Very good. 4 splits up into 2 and 2. 10 splits up
2 and 5.
2 and 5. And all of those are prime. So 40, once again, 2 times 2 times 2 times 5. As a fraction. 56. So in my mind, I'm thinking actually 8 and 7. 7 is prime. Now you could have used something else, right? Like 2 and, well, 28 looks like. But whatever. It doesn't matter which two numbers you use. You should get the same values either way. So I got 2 and 4 from the 8, and then 4 is 2 and 2. So this ends up, 56 ends up being 2 times 2 times 2 times 7. And then, to simplify this, I just cancel out all of the common factors with the numerator and denominator, and this ends up being 5/7. So let's look at this a little bit different than the way some of you did it. Let's look at 27 first. So this one, as far as I saw, it looked like everyone had that split up with 3 and 9. And then 9 split up with 3 and 3 at least. So the 27 on this part ended up being the easiest of the two. So let's look at 54 as well. So 54 splits up. I saw it divided by 3, right? And how do we know it's divisible by 3? Because 5 plus 4 is 9, which is divisible by 3. So to figure out what the other number is, we would take the 54 and we could divide that by 3, which would tell us the other number on that. 3 goes into 5 once, so subtracting, I got 24. 3 goes into 24 8 times, which is 24. So I'd have 0 remaining on that. But again, it's just to show that the two numbers would be 3 and 18. Now, I did see some of you use 9 and 6 on that, which is good as well. So 18 we can split up. Now that's a lot smaller number, a little bit easier to work with. Maybe you use 9 and 2. Maybe 6 and 3 as well. It didn't matter because 9 splits up into 3 and 3 also. So 54 ended up being 3 times 3 times 3 times 2.
I think you're missing a 3 up top.
I did. That's not supposed to be a 2 right there, dang it. Always check your work. That would have been really bad. All right, so we did see this as well, right? So the 3's cancel out these 3's and these 3's. So when we find the new fraction, I don't know what the heck happened there. It's equals. I've got the 2 in the denominator, but what number would I have in the numerator right there? Well, I canceled everything out, so what I can do is just give ourselves the identity property of multiplication and make that a 1 right there. Because if I took 27 and multiplied it by 1, I'd still have 27. So I'd just make that a 1. So if you ever run out of numbers and you've canceled everything, just put a 1 where that empty space would be. And that right there is our answer. So what that meant is in the beginning, 27 is 1/2 of the 54. That's just not a very common way to look at 1/2, but it still works. Compare the following fractions by using either greater than or less than or equals. So if they're equal, then we'll just put an equal sign between. If one's bigger, then it'll eat that one though. Okay, so the way we're going to compare the fractions is by using common denominators, because then we can see how many parts of that whole there would be. So if I had 6 and 8, a common denominator that I can use, the lowest common denominator I could use would be 24. Now that comes with some experience on that. But
6 times 8.
What I would recommend doing is just multiplying the 2. Okay? Right? So 6 times 8, and then 3 times, that should be an 8. So 3 times 8 is 24. 6 times 8 is 48. So this other fraction, I'm going to multiply those by 6. 8 times 6 is 48. See how that gave us the common denominators? So I know that all my piece sizes are the same size. 5 times 6 is 30. And I can tell a little bit easier now. If I had 30 48ths, that would be more than 24 of the 48ths. So this one ends up being less than. So what about this one? We could simplify these. It appears. No, maybe we couldn't. In any case, let's just go ahead and do the same thing we did on the last one, because it always works. I can take 63 times 45 and 35 times 45. So what does that give us? 63 times 45, 15, 31. I'm kind of going fast here to save time. 12, carry the 1, 24, 25. So that would be 25. All right, then I got 45 times 35. Times 35. So 25, 22, 15, 17. So adding these together, I get 5, 3, 9, 1. Those are big numbers, but again, the objective here is to try to find a denominator that is the same.
28.
So on this one, the next, we got 38 45ths. So we're going to multiply these two by 63. Now we already did 63 times 45, so we already know that denominator will be the 28 35. The only thing we got to do here is take 38 times 63. So 38 times 63, 24, 48, 50. 10's position 9, 18. Adding those together, 4, 9, 23. And we can see right here that 2,835ths, I got 1,935 of them, or 2,394. This again is less than.
I have a question.
Yeah, so I added up that wrong. So let me come back to this and fix that. So instead of the 1935, we should have had 1575. I apologize, I made that mistake, I think, because I'm trying to rush this. So try to take your time, especially on a test, okay? In any case, we can still see that the 2394 is more than the 1575. So with the clarification, we still get the same answer on that, which makes that kind of convenient. So that would be less than.